So, good morning, everybody, and welcome to hear my presentation on combining Symbian and Qt APIs for mobile app development, real-life experiences in developing applications with Qt to Symbian. First of all, I wish you all had a fun night yesterday, and I will start by telling something about me. My name is Tapani Puhakka, and I come from Finland, from the city of Oulu, which is about 2,000 kilometers from Munich, and I currently work as a senior software engineer in a company called Teleca. I have coded for Symbian since 2004, and recently I have been involved with mobile Linux development, and I have been using mainly Qt as a development language. And one project which I have made is this D-player, and when I was making that, I definitely saw a great benefit on Qt development compared to native Symbian, and the amount of work that was necessary to make that UI shine was a lot less. So there is a really great benefits in the Qt compared to native Symbian. In this presentation, I'm first going to tell you something about Teleca, the company I work for, and then I'm going to go through how this presentation or little study was made, and then I will briefly tell you the current status of the Qt development in Symbian, and then I will go to the main content of this presentation by listing issues, solutions, and recommendations found by our teams. And in the end, I will briefly go through some good habits of how mixing Symbian and Symbian C++ code and Qt code together should be done. And I will end up with conclusions. Okay, first about Teleca. Teleca is a company that currently works in 12 countries around the world. As you can see, it's probably sunshine, at least in some Teleca office at any moment of time in some country. We have around 2,000 engineers working, and we do work for mobile device operators, enterprises, and automotive segment. Here you can see the different industry segments we are currently working on, and we have noticed that these segments are currently converging together, and this is good point for Qt, because Qt actually fits very well in this kind of environment where you have to make same software work, for example, your fridge and your auto or car. I don't know what kind of software that could be, but there is a need to make softwares that are working in multiple different environments and multiple different segments. And Teleca has the history of bringing the best technology for this kind of solutions. We offer development work from the base porting to the application development, and basically can cover whole life cycle of the software engineering process. We offer consulting, integration, platform customization, optimization, application development and porting, verification and maintenance services to all major mobile platforms. A little exception here is iPhone, in which we don't have this platform customization and optimization services, as the Apple tends to keep it quite closed and with itself, so they don't use external partners to help with that. And then something about what Teleca has done with Qt. We have currently over 80 Qt applications made, and over 50 Qt framework projects. So there is a very high chance that the application you are using is either made by Teleca, or at least a phone that runs that application has some services that are made by Teleca. So we are pretty much involved in the mobile segment and Qt. There is some little examples of what kind of things we have been doing. Qt integration and optimization is a big part, and mobility API development and WebKit, and so on. Not all of this can be told loud, so what they are exactly, but you can guess. Well, in this presentation, I'm going to tell you about the experience Teleca teams have had. So basically what I did, I contacted 15 teams around the world from India, from Russia, from Finland, or from United States, and asked them what kind of problems they have had with Qt when they are making application to the Symbian platform. And I listed down these issues and listed down the solutions which they had those issues, and I'm going to present some of them in this session now. Those applications included web radio, some advertisement application, music mixing application, a couple of magazines, some banking software and transport software, and a couple of music players and some entertainment apps. All right. So the current status of the Qt is that the current stable release, which is also available for applications that are to be published in the Office Store, is 4.7.4, and the 4.8 is beta is already available, as you might all know this already. And what we heard from yesterday's strategy session in the big hall is that for the Symbian, the Qt 5.0 is not going to be implemented. So it seems that this is the status of the Qt now. And we can see also that there are quite many older releases of the Symbian. Series 65th edition, for example, doesn't, Series 63rd edition doesn't support Qt versions. Latest Qt versions, it only supports 4.6.3, which is pretty important thing if you are trying to target devices, or make an application that targets all the devices on the market. There are quite many of those older devices still in use, and to get a large customer base, it's very important to know what you are going to be able to offer them. So let's go to this experience then. When I asked about the experiences from our teams, how they see the Qt compared to Symbian, it was obvious that everybody says that it's a huge improvement over a traditional Avcon development. Making the UIs with the Qt is a lot easier, and it's a lot less error prone. In the best case, it deploys to the multiple platforms with a single source. You don't have to make any kind of hacks to the source code to make it run in different platforms. And the tools are very good, at least compared to what they used to be in the Symbian times. The Qt creator is actually very good in many sense. And the amount of code that is needed to make the applications work is a lot less than it used to be in the Symbian times, and the development in overall is a lot less error prone. And for many people who have been working with the C++ before, the learning curve is easier because there is not those Symbian specific things to learn, which made it pretty difficult to start coding for the Symbian. Well, from our experiences is that the Qt APIs typically cover over 90% of the needed functionality, but there are still gaps that the Qt API does not cover. And there are a few areas listed here: audio processing, video streaming, image manipulation, cryptography services, virtual keyboard, and so on, which we found out that have some limitations if you're trying to use only the Qt to implement those. So, solutions for problems? Yeah, of course. The Qt API, even though it is a huge API, it's not as huge as the Symbian API. Symbian has a lot more functionality which you can apply and usually solve the problems that if the Qt is missing some critical feature for your applications. Usually, best solution is do it with the native Symbian code. If you are aware of those limitations, you can make a design or architectural solutions in such a way that you are not going to run into those problems. And in some cases, clever UI design can be used to hide this problem. Even though it's there, nobody notices if the UI has been thought well. All right, then let's go to these issues. Our teams complained that locking the UI is not possible with the old Qt. It's of course nowadays it's already possible locking the UI orientation. Also, the finding if the flight mode is enabled or not is not possible with Qt. Volume up and key reading was not possible. Launching a native Symbian menu from the left soft, which appears by pressing the left soft key, was not possible with the Qt. And launching the browser or email application was also problematic using the pure Qt code, as if the browser was already running in the background, it caused the browser to just pop up with the existing content, but it didn't launch the new tab, which was necessary in some cases for our teams. And for detecting incoming phone calls, it was not possible with Qt Mobility 1.1, and I think it's still not possible even with 1.2. If somebody knows better, you can correct me. So for the solutions, for the screen orientation lock, you can use simple Symbian code to achieve that. Just select the orientation which you need, get the pointer to the AKN app UI class, and ask the AKN app UI to set the orientation to whichever you want. Even though this works without this Symbian code in the latest Qt releases, it's very important to know these kind of things if you are, as said, targeting devices, older devices, because they don't support the latest Qt release versions. And for the flight mode, solution is yet again use the native Symbian code, include the necessary libraries. Airtel third-party lib is very useful for this telephony-related things. And then create the C telephony object and ask for the flight mode. Of course, you have to also implement a little active object. And when the active object completes in the run L, you can read the flight mode status from the flight mode version 1 package. And in this example, it simply emits the flight mode status once the information arrives. And for Symbian code, it's also important always to remember to implement the cancel method also. And next, we had the problem of reading the volume up and down buttons. Well, that's possible with the Remcon API target observer, which is usable if you link against Remcon Core API library. What you need to do is create CRemcon interface selector and CRemcon Core API target, open the connection there, and then in the callback method you can handle the volume up and key events. And in this example, it yet again emits the new volume level. As you can see, in this example there is no limit on how high the volume can be, so maybe it's actually used to adjust the level of the flight for some game or something else. You never know. Yep. If you have questions, you need to have the microphone. Just wait a moment.
Hello. Regarding this reading the volume up and down keys, our experience is that this is only possible when the application is in the foreground. Is that correct?
Well, I'm not sure about this. So in your case, you had the problem that you needed to read the volume up and key when the application is also in the background.
Yeah.
Well, have to say that I'm not certain, because this is from one of our teams who needed this, but it might very well be so that. But if you want to know that, I can contact the team that made this and ask them if that is true.
Yeah, that would be nice.
Yeah. Okay. See you after this session, and I take you.
Yeah, thanks.
Yeah. And then there was this problem with one team that they needed to launch the native Symbian menu. They did try pretty many things with Qt code, but nothing works except this sending the this event to the event loop. Well, this is pretty easy, but if you don't know this, know how to do it, it's pretty difficult to open the native Symbian menu. Just send that event and it will pop up. And for this browser email application launch problem, well, as I said, the problem with the Qt solution is that in the Symbian devices, it only brings the application foreground if it's already running, but it doesn't open the new tab or new email if it's, as said, in the background. But if you want to do this correctly, you can use the Qt API task to do it properly. Here we have an example of how this Qt API task can be used. Ask a Qt API task list to find the application with the UID you want, and then check if it exists. You can bring it foreground if that is what you need, or in this another case, you can, for example, kill it, so you can be sure that it's not running in the background. And for detecting the incoming phone call, well, the Telephony API is the thing that helps you again. What you need to do is register for changes in e-voice line status change and implement the active object again. And once the active object completes, you know that there is some status change happening, and you can, for example, in this case, emit a signal that a phone is ringing. This kind of functionality might be necessary, for example, if you are implementing a music player in which you need to handle the situation where somebody calls during the playback correctly. So the Symbian will make sure that you will not be able to play the music. But what you do after the call has ended? Well, with this kind of solutions, you can resume the playback. All right, there was a bunch of issues, but what would be more fun than continue with more issues? So, a couple more. Well, one of our team complained that launching the camera in full screen view with the context of the application is not possible with Qt Mobility Camera API. Also, there was complaints that reading and setting all details of phone profiles is not possible with Qt, and that getting a list of applications that are installed in the device is not possible with Qt. Well, for launching the camera, the team applied the solution that they actually use this little Qt code to launch the native Symbian camera application, and then just simply monitor the state of the camera application. And I assume that when the application is no longer running, they check for the latest images added to the device and process them as needed. For reading and setting phone profiles, well, that is also possible with the Symbian code by linking to the profile engine library. And to get the profile, ask the profile engine for the profile name array, And from the name array, you can then ask the ID of the profile, and then again, you can use the profile engine to get the actual profile with that ID, and from this profile, you can get the details of the profile. In this example, it gets the profile name. And well, if you want set some different profile into use, you can use a profile engine set active profile after finding the correct one. And for getting the list of installed applications on the device, what you can do is connect to the API or application architecture server API LS session and ask it to get all the applications. And in this example, it loops through all the applications it gets from that application architecture server and checks from the capability if the application is hidden. And in case if it's a hidden application, you probably won't want to display it on any lists because it's not supposed to be visible to the user. There is also a little example how the Q string or how descriptors are converted to the Q string. Yep. Also, there was one team that complained that the Qt keyboard is not Qt because it doesn't work the similar way as the Symbian native keyboard does. There is no copy and paste support in the Qt keyboard. Also, the Qt keyboard is always full screen, even in those devices which nowadays use half screen keyboard in the native Symbian applications. And there is no possibility to copy or paste text from the Qt virtual keyboard, even though it's possible to select that text. And the multi-line editor only shows one line of text, even though there would be space for up to 5 lines, like they do in the native Symbian applications. And these little differences in how the virtual keyboard works make it inconsistent behavior between the Symbian and Qt applications. Well, for solution for this, you could always consider creating your own keyboard, but it's something that I wouldn't really recommend to anybody because it's pretty difficult to make it work correctly in all different language areas. So what you usually will end up doing is leaving what you got and trying to make your UI design in such a way that those little inconsistencies don't bother you too much. So don't make anything that where user thinks that he can copy-paste text from that keyboard. And also the teams complained that there is not enough support for web services. There is no ready-made Facebook API in the Qt, and there is no share UI type of functionality in the Qt, the kind of which you have in N9 that allows you easily to share stuff to the Facebook, for example, sending some links to your wall and so on. And also what makes this even worse is that the Qt Crypt is not available in Symbian devices at least in the older Qt versions. So also the DSA cryptography is not available because usually when you will need those cryptography services when you are making your own implementation of Facebook client-side API in the handshake and when you are authenticating to the server. So what is the solution for this? Is use some existing library if you can find something suitable in which contract issues, stability, support issues, and so on are all okay. Or you can implement the wheel by yourself again, which is the usual case in when handling the Facebook issue, at least. Everybody does it again time after time. Little guidelines on how Facebook integration works. You need to use HTTP GET and POST and browser control API. It's quite difficult to do well. Facebook APIs are not that well documented after all, and Facebook has tendency of changing its website, so you might run into compatibility problems. And okay, there is this one issue that which one team complained that the current API only gives callback when loading of initial URL has finished, but there is no second callback if there is a redirection to this different address. Some problems. And when you are implementing your own Facebook client-side API or something like that, you probably need these cryptography services. Well, happily, Symbian offers a huge amount of support for cryptography. In this little example, we create a signature to sign the message with private key for DSA. It's pretty simple. Create the signer, create the SHA, create the hash, and create a signature from that hash. It's not, of course, full example, but just to give the idea how it works. Also, one team had the issue that it's not possible to mix sounds in real time with Qt. So it must be implemented with native Symbian. There is a good example available how to this sound mixer stuff can be made with the Symbian code in the developercom site. And some little hints on what to take care of is that threading must be implemented, audio mixing and playback must be in different threads, and UI redraws, well, very good idea to keep them in minimum. Symbian 3 devices take more time in redraws than the previous ones. And one very important thing always when making audio application is to remember that different Symbian devices have different kind of support for audio codecs. For example, the mobile XMF and MIDI support are missing from N8, and real audio 7 and 8 are no longer available in Symbian 3 devices. All right, there were some issues our teams had run into. Well, let's go now through some things that you should do when you are implementing the Symbian C++ and merging it together with Qt code. Using the pointer to implementation idiom or pattern is a very good idea. You want to hide the Symbian implementation as well as possible from the actual Qt code, which is cross-platform code, and the Symbian code is only for the Symbian platform. Also, handling the leaves correctly, it's important because you don't want the leaves leaking to the Qt code. Or another way, you don't also want the exceptions to go into the Symbian code because they are not handling those. So make sure that there are enough barriers between the Symbian and Qt code to handle the leaves or convert the leaves to the exceptions and vice versa. And for Symbian, when you're coding multitasking, you're probably ending up using the active objects. And well, doing that correctly is important. I have some little example what could be done to make it work correctly. And when coding with Symbian, you have the Symbian coding standards, and with coding with Qt, you have Qt coding standards. Good thing to remember here is that all the Symbian code should be made using the Symbian coding convention and so on, and all the Qt code with Qt coding convention, so don't mix them up. And of course, you will end up problems that you have to convert Symbian data types to the Qt data types and Qt data types to Symbian data types. Some of these are very easy and straightforward, like size and point structures, which you just they are basically same, but you just have to construct a new one with the Symbian version. But some might require a bit more work. There is actually a very great guide for the Nokia on how to do this correctly. It's available on the Qt Nokia.com, and it's called using Qt and Symbian C together. So about this pointer to implementation idiom, the idea of this is to make all the Symbian specific implementation reside in the private class, which is not visible to the user or the client of this your API, whatever it want to do. So what you do is you make ifdef to check which version of the header class files you are going to use. If you're in the Symbian platform, you include the Symbian specific, and then there might be some other platforms that use other implementations. And then you have this private pointer here, which actually implement the Symbian code, and in all the slots or the functions your API offers, you just redirect those calls to the private implementations. And what is important also is to make this private implementation a friend of this your actual public API class, so that it can call the signals or emit the signals from this actual main class. Yeah, and also you have to remember to add a similar kind of condition to the project file, so that you compile on the correct CPP files depending on the platform. And for handling the leaves and exceptions, Qt offers a pretty good set of ready-made macros that can be used to handle these situations. And then about making the active objects correctly in Qt. Well, first of all, use this pointer to implementation idiom to hide the active object class. And what you need to do is map the public functions, which starts the active object in the public interface in this simple idiom, and in the active object emit the signals when this public interface when the active object completes successfully or unsuccessfully, so that there is error handling in the client side also available. And in this example, you also see how the code is catching the exceptions in the active object, just in case, because if you are connecting this signal to some slot, you never know if the slot is going to actually throw an exception, and you don't want the exceptions going into Symbian code. So good way to prevent that is change them to the leaves. All right. And then with this a little bit about converting the data types. For string conversions, it's pretty handy using the QString from UTF-16. Just give the descriptors pointer and length as a parameter, and you get the new copy of as a QString. Or you can create a descriptor that points to the existing. You can create a QString that points to the existing descriptor without actually copying it by using this from raw data. And again, get the descriptors pointer and convert it to the QChar and get the descriptor length, and that's it. And for another way around, I only have the example of how to make a descriptor that points to the existing QString. So Similar way, give the UTF-16 pointer of the queue string and the length of the queue string to the descriptor, and you have the working descriptor. In this example, if you're using this, you have to just make sure that the queue string stays alive. So as the queue strings are reference counted, you have to keep at least one reference valid for that queue string, so that this descriptor doesn't go invalid and cause crash at some point of the execution. And then some general concerns when working with the Symbian devices. Symbian devices, at least if you include all the older models also, they come in very, very many forms and sizes and specifications. So in this list, I have only pretty new models, but you can see also between these devices there are huge differences. The screen size, well, it's many of the models have the very same screen size, but it actually makes a difference if you have 4-inch screen compared to 3-inch screen. The amount of space that is necessary for the UI elements is quite different, at least on my fingers. And also the screen resolution is many times different between different Symbian devices. There might be differences in the RAM and processor speeds, and what kind of keyboard the Symbian devices have available. There are QWERTY keyboards and touchscreen only, and I2T keyboards and so on. So all these need to be considered when you are trying to make application which targets multiple different Symbian devices. It's not as easy as it might be with some iPhone or something. All right. In case there wasn't enough solutions yet, you can always go to the developercom and check for knowledge base for technical solutions. It contains a huge amount of solutions for different kind of problems people have run into in their projects and so on. So I really recommend this one as a starting point if you have some problems. And now we can proceed to the conclusions, I think. So what we have done at Teleca is we have implemented multiple applications for Symbian using the Qt. Our observations show that Qt offers a great improvement in UI development speed, but there are some gaps in detailed control on device and phone features and so on that are not yet implemented and require Symbian APIs to be used. Symbian API, on the other hand, contains a lot of functionality and can be used together with the Qt code. But of course, when you end up mixing those code, the portability of the application suffers a little bit. So it's always best to have used the Qt solution if it's possible. And not having the Facebook API, client-side Facebook API available in the Qt forces developers make their own solutions, and there is some stability issues with own solutions because they are not as well tested as the SDK version would be. And of course, as previous slides showed, there is also compatibility concerns between the Symbian devices because they come in such many forms and sizes and specifications. And as a final thing, I would say that over 90% of the code can be made with the Qt, but sometimes you need to use the Symbian APIs and merge them together with the Qt code. And this requires some knowledge on how the Symbian APIs works and how the Qt works and how to do this correctly. All right. Thank you for listening to me, and if you have some questions, you can raise them now.
Yeah. Do you have any experiences with the Qt Mobility API? Because on X65th edition, it's officially supported, but there are no binaries for the current version anywhere.
No binaries?
There are no binaries for the Qt Mobility API, no sys packages or something for Qt Mobility 1.2, although it's officially supported for a for Symbian 1, so to speak, so a 65th edition.
Well, I don't quite understand that Nokia shares these packages for.
Yeah, the packages are not available. They are not delivered with the Qt SDK, and you cannot download them anywhere.
Are you referring to Qt Mobility 1.1 or 1.2?
1.2.
Well, I don't have experience on 1.2, but at least 1.1 is available.
1.1.3 is available. 1.2. No, that's 1.2. Yeah. 1.2.0.
Yeah, I think if there is such an issue, it's good to tell some Nokia guy here that please.
I did. Don't. I did.
Yeah, so it definitely should be available there.
The answer was quite funny. I have to move with the time.
All right.
So was actually the deprecated feature?
No, it's not deprecated. It's officially supported, but not available for download.
Yeah. Yeah, there is some of those issues with Nokia that not always, well, it sometimes shares a little old stuff and sometimes it doesn't share the new stuff. But usually if you contact them, they will help you with that issue. I don't know, hopefully you can solve that. Oh, is there any other questions? All right. Thank you, everybody, and please come visit our stand, and you can see some of those demos running live, maybe there.